Hey, your sevens. So today we're going to get started on our new unit or topic called probability. When you think about probability, think about how likely or what are the chances of something happening. What are the chances of it raining? What are the chances of you winning $1 million? What are the chances of you tripping down the stairs? Those would all be examples of probabilities. When you think about probability, we can start using words to describe probabilities. And really in today's lesson is all about the vocabulary of probability. So we're going to talk about the vocabulary of probability. And one place to start with the vocabulary of probability are with words like impossible, which means that there's no chance of that happening. Or there's words like certain, which means that there's a very likely, not very likely, that something is definitely going to happen. An example of something that is certain would be like the sun rising tomorrow. So if you can think of the sun rising. Now whether you'll see the sun rising because there's clouds or whatnot is a different matter, but the sun will rise tomorrow, and whether we see it or not, whether we're awake or not, whether there's cloud cover or not, are all different probabilities, but the sun will rise tomorrow. So that's something that's certain. Something that's impossible, something that it will not happen, would be something like rolling an 8. On a standard die or 6-sided die. So those would be examples of something that's certain and something that's impossible. The other thing in high school that we can start thinking about when we talk about probability, or we can start assigning values to these ideas. We can think of something being impossible having a 0 assigned to it for its value, and something that's certain having a 1 assigned to it to mean that it's very, very possible to happen. So 0 and 1 would be kind of the opposite ends of the range for probability. Something else you probably heard people say is a percent chance. We can all use percents. From over here, this would be a 0% chance of something happening. Certain is something that would be definitely 100. I wonder if I can move this little box. I can't. 100% chance of something happening. And so you can use percents to also represent probabilities. And you've probably used those. There's 0% chance of that ever happening is definitely a phrase that I've heard used before. Over here in the middle, something right in the middle, and this is something that you can think of as an even chance. So that would be, let me just change colors so it's a little bit easier to see. This would be something that has an even chance. Something that's an even chance would have a 50% chance of happening. I keep pressing the undo button and not writing 50. There we go, 50. That would be something that's 50% chance. The other way sometimes people say it is a 50-50 chance. I've also heard people say 50-50. Of happening, if you think of a coin and flipping a coin, usually the chances of getting either side of the coin would represent something that has an even chance of occurring. With the coin flip has two sides, you can either get heads or you can get tails. Fun fact, a Canadian coin, the nickel that we all flip at home, does actually have a tail on it with the beaver. And that's one thing that we commonly use for determining heads or tails is a Canadian nickel when we have to do that. We can further kind of break up our line that we have here when we talk about probability. We can use the term likely. Something that's likely to happen is better than a 50-50 or even chance, but it's not certain. So it's there on the number line, and the opposite of that, or something that would be less than even but greater than impossible, would be something that is unlikely. I'm trying to squeeze this in without making it too messy. So after unlikely, then you can start to even break this up into more partitions. We can look over here. If something is more probable to happen than likely, but less than certain, you can say it's very likely. And then if you had something that was, less likely to happen than unlikely, but more than impossible, you could say it's very unlikely. The chances of me winning the lottery are very unlikely. I don't even know if I'm allowed to win the lottery while I'm here. So in our example, we're going to use our scale that we've created above, and we are going to mark the position of each event described above. So, A, it will be hot tomorrow. Well, seeing as we're in orange, and it's considered to be, I guess it's the late fall or autumn, early winter, I would say it's probably unlikely it's going to be hot tomorrow. I haven't looked at the weather, but we'll just go with A right here. So I'd say the chances of it being hot tomorrow are pretty unlikely. B, the sun will rise tomorrow. Well, I already kind of used that in our example. B, over here right by R1 or by certain that the sun will rise tomorrow. C, there will be floods in your town this year. Well, this is like a trick question for me, but I'll answer it first from the orange perspective. There will be floods in orange this year. I've heard that it is unlikely that while I'm in orange this year, there will be floods. If I was at home in Bracebridge, however, I'd be marking it actually over in the likely phase. Each year in Bracebridge, when the snow melts, we get usually some amount of flooding that happens. The last 2 years, it's been quite pronounced flooding. And this year, I believe it's quite less. But year to year, on a yearly basis, it's likely that flooding will happen at home when the snow melts in the spring. But I'll keep it for an orange answer for C. D, there will be no car accidents in City tomorrow. So the first thing to make sure to pay attention to is wording. So that there will be no car accidents, 0 car accidents, not a single car accident will happen in City tomorrow. So from what I've been led to believe, I'm told that actually there are a number of car accidents that happen in City tomorrow. So I'm going to even say that it's going to be highly or very unlikely that there will be no car accidents in Sydney tomorrow. I would wager that there's a good chance there will be a car accident or 2 in Sydney tomorrow. And finally, E, there are more than 5 people at your home at the same time today. Well, seeing for myself that I have exactly 4 people in my house, and seeing as due to current restrictions, there's not a lot of visiting going on, and we don't really know many people, I'm going to say that for us, it's E. It is impossible that there are going to be more than 5 people in my house at the same time today. I might even keep it at the very unlikely. You never know. 2 people might come over, maybe from neighbors, but I'll go with very unlikely. But for me, I wouldn't say impossible, but I'll go with very unlikely. For you, you might have 6 people in your family, including all your siblings. And so for you, it might even be certain that there's going to be more than 5 people at your house at the same time today. So for you, it might be slightly different, but for myself, that's the best answer for me. So I'm going to move on to our actual terms. So the terms of probability work like this. So the first thing we have is we have something called an experiment. An experiment is any situation that involving chance that leads to the results called outcomes. So for example, it could be like flipping a coin, rolling dice. For here we have a spinner, spinning a spinner. All of those are examples of experiments where you have a probability or a chance of one outcome. So the chance of me rolling or spinning a yellow, or spinning a red, or spinning a blue, flipping a heads, rolling a 6, all of those would be experiments. A trial is only one go or one run of an experiment. So if I just spin the spinner once and I'm going to see what the result for that one trial of the experiment is going to be, I can then see what that is. The outcome is what happens as a result of that trial. So or the experiment. So it could be rolling or spinning a green or spinning a yellow, spinning blue. And the sample space is all the possible outcomes. So for our spinner above here, our outcomes are red, blue, green, and yellow. Obviously, our spinner reflects that, that's the chances. An event is one or more outcomes of an experiment. So I could ask you what are the chances of the event of the spinner arrow landing on a traffic light color. So that would be a red, yellow, or green color. And I could kind of ask you that. Those would be, that would be an example of an event. Finally, a random experiment is an experiment in which every outcome has the same chance of occurring. So in this situation, because each of our sectors above here are the exact same size, this would be an example of a random experiment because they all have an equal side or equal chance. If I had a coin that was heads and a coin that was tails, in that situation, we would have a 50-50 or 50%, or if we talk about our actual 1/2 kind of probability, there's that equal chance of heads or tails, and that would be another example of a random experiment. So finally, we're going to classify each of the following statements about probability true or false. So A. It is likely that children will go to school next year. True or false? I would say there's a very good chance of that, and I would say that's a true likelihood of that happening. B. There's an even chance for a fair coin to display heads. So again, if I had a coin that had heads and a coin that has tails, I really have of my two possibilities, really, it's an even chance of me rolling heads versus tails, as long as the coin is, as it says, it's a fair coin, so it's not weighted or not set up in some way that one is more likely than the other. So again, that would be true. C. Rolling a 3 on a 6-sided dice and getting heads on a coin are equally likely. So when you think about it, how many sides are on a coin? Well, there's 2 sides on a coin. How many of those sides are heads? One of those 2 sides is heads, so that's a 1/2 chance or a 50-50 chance. So let's talk about a dice now. So there's our coin. That's getting head on the coin. Now for a dice. Well, how many sides are there on a coin? On a dice. You notice I'm making fractions here. So on a dice, there is 6 total sides. So our denominator is going to be 6 because that's what the total group is. And how many of those sides are a 3? Well, there's a 1, 2, a 3, 4, 5, and a 6. So only one of those sides is a 3. So that's a 1 out of 6 chance. So is a 1 out of 6 the same as 1 out of 2? It is not true. And so it's saying, is it equally likely? They are not. So this is false. Ooh, that's false though. False. So for D, with D, it is certain that 2 randomly chosen odd numbers will be added to an even number. Okay, so let's take 3 and 5. 3 plus 5 is 8. Okay, let's try. I'm going to do a couple experiments here. So we're just going to do some experiments. Let's try 1 and 9 makes 10. Let's try 3 and 7 make 10. 7 and 9 make, I'm just trying to keep single digits here, make 16. So you notice every time I'm adding an odd and an odd together, I'm making an even. So I would say that D is also true. I hope this has helped you out and think about probability and be able to do your practice. Hope you're taking care of yourselves. And for those of you here in class watching this video, I hope you're also doing well as well. Take care.